Great. So let's get started. I'm going to start by telling you guys a little story. So what would you do if somebody asks you the following? There is a team of junior devs that needs a place to deploy their app. Can you help them? There are a lot of ways to answer this. So we could start by giving them SSH access to some VMs and tell them, hey, good luck. But that's not great. It's be like leaving them to the wolves. You could give them a managed Kubernetes service like EKS or similar, but we're cheap and we don't want to spend that kind of money. We can take this as an opportunity to look at some cool new technologies and pick one to try out and learn something. So that's what we did. So we started by creating a half dozen VMs with Terraform. We moved on to setting up Nomad and Consul on them with Ansible scripts, and we helped the developers grow towards a 12-factor app style of logic. And honestly, this was a pretty great success. We put their backends, their frontends in Nomad, and we lived happily ever after. Except, what about the databases? So that's what brings us here today. Me on the left, José Maia, on the right, Carlos Cunha. We're two members of the IT Ops team at Critical TechWorks, which is a BMW Group company. Our team's mission is delivering high-performance tools, connections, and support to development teams, allowing them to work fast and efficiently to high-quality standards. What this means in practice is that we spend a lot of time learning about and tinkering with some technologies, as well as sitting down next to our colleagues, either virtually or physically, and helping them achieve whatever their goals may be. So before going back to our story, I'm going to explain a little bit of the concepts behind what we are saying here. So what is Nomad first? Nomad is a workload orchestrator. It's compatible both with containers and non-containerized applications. It's very simple to deploy and operate. It's basically just a single binary. If you use Consul together with it, it's two binaries. And I recommend you do that because Consul gives you a lot for free. So service discovery, auto clustering, and a lot more. I kind of usually sell it to people with the 80-20 rule. With 20% of the effort of something like Kubernetes, you get 80% of the capabilities. Another concept that I like to introduce here is stateful containers. So we know that containers are generally meant to be ephemeral. What about when you want to containerize an application that needs to keep state? If you have no idea on which of your VMs on your cluster the stateful app is running, how are you going to make sure that it has access to the data it needs? There are a bunch of concerns here, attaching and detaching the disks, making sure they are on the right machine, making sure they have the right permissions for the mount. This is a very complex problem, and some people recommend you don't run databases in containers. There's a couple of links here in the slides that I recommend you check out and participate in these discussions if you want. But maybe you have considered those risks and you only want to do this in some controlled scenarios. For example, you want to do this in your development environment. You want to do this for your Jenkins, for your Sonar Cube, for your Nexus, and maybe not for your production apps. So you've planned this all out and you say, okay, cool, I still want to have stateful workloads. How am I going to do this? And a possible solution is CSI. So what is CSI? Container Storage Interface. It's a specification that allows writing a single plugin called driver for a particular type of storage that will work with every single orchestrator that implements this standard. There's already a very large list of drivers for something so recent. Some examples are AWS EBS and DFS, GlusterFS, Azure Disks, and you can even, if you have a Synology NAS at home, you can even use that for CSI. It's pretty cool. This diagram basically sums up how it works. We will have more details in the demo parts, but essentially your container orchestrator communicates via gRPC with a series of node plugins and controller plugins. So as the name say, node exists in every single node and controller is centralized. So back to our journey. In November, we were told, hey, we want to get the junior devs apps in production by the company Christmas party, so we have something cool to show. Okay, we kind of panicked a little bit, let me tell you. But it was a relatively limited problem space, so we only had 2 applications, which means 2 Postgres databases, and a limited amount of users, so we weren't going to have any scaling issues or anything, because these are internal apps, so it would always be a percentage of the employees of the company, which at the time were like maybe 600. So we said, let's give it a shot. Nomad 0.10 at the time had support for host volumes, which is basically bind mounts. So we simply applied pre-existing logic, which we had done for our previous more manual deployments, and said, okay, we will specify that application X always runs on VMY, which has a folder Z with a database bind mount. If you want to do backups, if you want to do restores, we know that's the machine, specific machine. So it worked, but as things went on, COVID hit, and we had yet another internal application to deploy to the cluster that was used to manage seat reservations at the office so we could stay under the guidelines by the national health organizations. And as we were working to deploy that app, we kind of realized that keeping the bind mount structure was causing us a lot of pain. Every time we needed to change something, we would have to spend a lot more time than we wanted doing, stopping the jobs, backing up, upgrading VMs, etc., etc., etc. And we decided, okay, let's investigate if we can find something better, but also taking advantage of the technology stack that we already use and are comfortable with, because we were enjoying using Nomad. So at the time this came out, 0.11 came out with the beta for the container storage interface. And we said, hey, why not? Let's give it a shot. Let's see if it works for our requirements. So we decided to start with the Azure Disk plugin at the time. We were only working with Azure, all the internal apps run Azure. So we said, this is probably the easiest for us to adapt. It's what we are already comfortable with. And we went on and did that. And after some efforts to get it working and some contributing back to the open source projects, for example, there were some cases where the Nomad documentation wasn't entirely correct, or there was something that was not applicable if you did an API request that was correct for the Nomad CLI. Some inconsistencies there that we contributed to and raised some issues, and we always have great response times by the HashiCorp team. After this effort, we managed to get CSI working correctly and migrating everybody, including backing up everything, restoring everything, getting everything working with CSI, worked fantastically. Well, I say flawlessly, but we had an issue, but it was DNS. It's always DNS. Other than that, everything was great. Before moving on to our demo, I'd like to talk a little bit more about some of our pain points and some of our positive results. We have a pretty stable and reliable system. We have had this running for a few months now. The only big pain point here is the integration with Azure. The Azure CSI driver isn't as stable maybe or as tested as some of the others in this context. So sometimes things happen that it cannot recover from and it requires manual intervention. We are keeping an eye on development and bug fixes that may exist, updates that may come to the driver itself, and always taking care to participate in the GitHub issues and keeping an eye on things from there. Another thing that I'd like to talk about, which was a great success, was the move from design to production and the adaptation to multi-cloud. So to give you an example, we have implemented the entire stack on Azure, then we implemented our entire stack on AWS, except for the step regarding implementing CSI. So we had the VMs, we had Nomad, we had Consul, we had everything. We just wanted, okay, now let's get the apps in production. That step took me one workday. From having empty VMs to having Jenkins, SonarQube, Nexus, etc., everything running with CSI as a support to the data. It was really great, really nice experience. Another highlight that I want to share, I talked about this a little bit in the previous slide, was the contribution back to open source. Knowing that somebody else who wants to go through this experience will have an easier time than us was honestly very heartwarming. And thankfully, we were lucky to be supported by our management in this. We always went, okay, we want to contribute to open source. We want to be able to fix the documentation if something is wrong or write a PR for something that we want to implement. And we were always supported in that, and it worked out great. So this is pretty much everything that I have to say from the theory side of things. So let's get our hands dirty. We're going to show you how to get this working with Terraform and Azure. All of the code is available on Carlos's GitHub. Unfortunately, this demo is going to have to be pre-recorded because we had some technical issues. I'm just going to change my new share. Just give me a second. Okay, I'm going to get this playing.
Hi everyone, my name is Carlos and I am excited to talk to you about CSI Nomad. Let me just start to say that every code used in this demo will be available to you on my GitHub page, and there will be a link to it on the slides. First, let us take a look at the infrastructure in place for this demo. We have set up an Azure resource group with 4 VMs and 2 managed disks. On the compute side, we got one VM that will be hosting both Nomad and Consul servers and 3 dedicated clients to handle workloads. On the application side, we will be hosting traffic as our reverse proxy, and in order for us to demonstrate data persistence, we'll be deploying pgadmin and SonarQube, each of them with their own Postgres database. So let us take a look at Nomad States. As you can see, we have here no jobs, no workloads running, and on the storage side we have no volumes registered and no plugins in place. So the first step in our demo is to deploy the plugin and register the 2 disks we have previously created in Azure. For that, we will use a previously created Terraform to do that. While the plugin workloads are starting, let's get an overview of the process happening in the background. As we already said, CSI requires a node plugin and a controller plugin to function. The controller part is responsible to interact with the storage provider, in this case being Azure, and request attach and detach operations. We will have 2 running controllers for redundancy purposes. On the other hand, the node plugin is started as a system workload and starts in every client where the jobs are run. The tasks associated with the node plugin are mount, unmount, and format operations. So, as the plugin is started, let's see if it is healthy and if you have everything running as we should. As we can see, we have the plugin, the controller, and the node both healthy with 100%, and you can see that here we already have the 2 volumes registered with no allocations as it's supposed to be. So, being the plugin deployed, we can start to deploy our applications. Okay, we are starting traffic, pgadmin, and SonarQube. You might notice that jobs that use CSI volumes take a little bit longer to start, and that is to be expected. A CSI plugin needs to attach the VM, thus the disks onto the VM, and then mount them. Only after that operation is done will the workload start. So we have here all jobs are started successfully. Let's see the services inside them. We have the databases already started, and we are waiting for the frontends to load. Okay, SonarQube has already gone up. Let's try and access SonarQube. Okay, it's starting. While SonarQube is loading, let's check pgadmin. Okay, it started now. Yeah, it's okay. So let's start with pgadmin. Let's log in. Okay, it's running. So we created the database and preloaded some dummy data, which we will now change. So here, let's change here a comment. And let's save this. Okay, now we changed some of the records. Let's see SonarQube here, just see. Yeah, we have here previously created, the data has been loaded. Yeah, it's all working properly. Now that we have our workloads running, let's simulate a maintenance window in one of our servers. For instance, we need to perform a shutdown of some client. Let's check which client we want to shut down. For instance, let's say that Nomad Client 0 is wanted for downtime, for some maintenance. So we have to first to get the node ID of the client. Okay, Nomad Client 0, it's this ID, and that's enable drain node. For this demonstration, we'll not train system workloads. Okay, as you can see, Nomad start to redeploy the job. Evaluating the job again, relocating it to another client. In the background, again, CSI is requesting to unmount and detach the client being drained, and it will attach and mount to the destination Nomad client. As you can see here in the topology, the workloads are being moved from Nomad Client 0 to Nomad Client 1. Okay, so let's wait for the services to be up. This can take a while because we have this background operation taking place. Okay, let's wait. Database is already up. Let's wait for the front end. This always takes longer than demos, as you know for sure. Okay, it seems to be up. So let's refresh here and let's log in again. Okay, so let's try and check if the information that we updated is still there. So HashiTalks 2021 rocks, so it's here. As you can see, the data was persisted, and we can effectively use CSI to handle stateful workloads in a more easy and dynamic way. I hope you enjoyed this presentation and that you are excited as we are with regards of CSI. We believe that once the feature set increases, it will be a game changer for Nomad, and it will lead to greater adoption by all of those wanting to handle workloads more efficiently, but still being not able to face complex activities. We are available to sort out any doubt that you may have in the chat. Also, if you have any comments, questions, or feedback regarding this presentation or even CSI, please reach out to us. We will be glad to be of assistance.
So yes, that's all that we have in terms of the talk itself. Thank you very much. Carlos, if you want to also turn on your camera.
Hi, sorry. I hope you like the demo. Sorry if we couldn't make it live because of technical issues, but we were just to make sure that you have all the content and not leave with a still frame or anything.
I love the demo. I kind of mistyped in the YouTube chat but I thought it was a really cool demo. I'm not gonna lie to you. That's one of the first times that I've ever seen the sort of it used like that, and just really, really cool. Like mind-blowingly. I genuinely, I said this earlier to you, Jose. I thought this was so much harder than it is. And okay, I know it's not super easy, but just the power behind using CSI. Now, I have a question for you.
Sure.
Was your Nomad server running locally whilst you're using Azure storage there? Like, am I misinterpreting that?
You cannot do that because you have to have the clients run inside the infrastructure they are using to mount the disk. So you have to do all that in Azure or something like that. You cannot use local or on-prem servers with cloud storage. That doesn't work.
I wasn't sure. It was just like I was a little confused by the .local domain on your
Oh,
cluster there.
I used some DNS, some local on hosts I have there on the GitHub, so it's easy for you to access the dashboard, and it's a common place for all the demos. Each one will have a different IP on the Terraform output, so we just have to have a clear sight of what was the links and the domains for everyone. We just started from there. So.
But yeah, that's really nice. I mean, being able to not having to open up UIs and API servers to the whole world is a very good thing indeed. So I've got some questions around the CSI. So you showed us using Azure, but because CSI, Container Storage Interface, is a standard, the applicable process will work anywhere on any cloud where there is a driver, as well as working with. Can you do sort of more on-prem storage type things? Like, can I work with like an NFS server or anything like that with CSI or the drivers around this?
The only example that we've actually put some serious time into was AWS, other than Azure. But as I said in my part of the talk, there's a bunch of drivers. Yeah. Like the one that surprised me the most was actually one for the Synology NAS. If you have one at home, a network attached storage, you can go, hey, I can put CSI here. I didn't try it out, but it's cool that it exists.
I think it's very cool for building home labs as well. As well as you've been able to kind of have a home lab, which translates very, very closely to production, is a really important learning thing.
But there's absolutely a ton of supported plugins, which I'm sure will support most standards.
Yeah, I think the drawback still here is, and we are being somewhat limited because on Kubernetes it's more a complete ecosystem. You can provision, you can clone, you can do lots of stuff. But on Nomad still we have still the basics is still on beta, so we have just the provision and the usage. So we don't have resizing operations, and I think with the feature set increasing, I think it will be a very cool thing to see, to have a much more dynamic environment here.
Yeah, I mean, the team is working incredibly hard on making sort of the CSI experience around Nomad a lot more sort of feature rich. It was a very complicated process, because a lot of the integration around CSI, and even though CSI is kind of like standard, really a lot of the integration points are predominantly focused around sort of the Kubernetes ecosystem. So being able to kind of get that translation working with Nomad was no mean feat. But I was very pleased to see it happen, and also with sort of networking side of things as well, being able to do those integrations with very important standards like CSI. And
I think it will be, as soon as we get this adoption going, to have much more examples, because the only cloud that there is examples posted is on AWS, which is most commonly used. You have one here because on Azure, but we've seen lots and lots of people doing things on the GitHub, or issues with Ceph, and with lots and lots of providers out there that people use. And I think it will be great to have some more examples and people sharing those interactions, and to see how they are solving the problems and whatnot, because it's been hard to look for documentation.
And this, I've said this a bunch of times, and I'm going to continue to say it. This is why we value community members like yourselves coming and giving talks to us, to the community about these sort of topics, because at HashiCorp, we're not experts in sort of all of the various different sort of implementations of cloud and sort of the various different sort of storage drivers, and for people to be able to come along who are experts in sort of the way that Azure works and be able to present an example is really, really beneficial to the community. And we're very thankful that you ahead and do that. And I'm pretty sure everybody will agree with me. It was a super cool talk, and really, really cool fact that we've now got that artifact as an example, which stands for the community.
That's also the part of the mindset that we appreciate, and why we enjoy working with HashiCorp tools is precisely because of that community-focused mindset.
Yeah, in doing this demo, I actually discovered the bug on our infrastructure, and I have a GitHub issue, and I got an email from Tim Gross now during the session. He's helping me debug some stuff. So yeah, it's the people on the has been great, and yeah, we had lots of support.
Well, thank you so much. And I'm hoping that I'm going to see another killer demo from you next time we do Hashi Talks, and then the next event later on in the year. Yeah, and everybody who's presented today. So thank you so much.